Hello friends! While I was doing research for a Metroidvania course for Godot, which is available on Patreon for early access by the way, I found a lot of tutorials animating 2D characters using an animated sprite 2D node, and writing scripts to control the animations using a finite state machine. This seems logical, but it's a trap. These tutorials never include combat mechanics or anything that would require synchronization of any other mechanics with sprite animations, such as adding invincibility frames to a dodge animation, activating a hitbox during a specific frame of the character's attack animation, or producing sound and particle effects synchronized with the character's footsteps. These dust effects are a better use of the animated sprite 2D node since they don't need their animations to synchronize with anything. They just play once and are removed from the scene. If you want to synchronize anything with your character's animations like this, you'll need to use the animation player to animate a sprite, rather than relying on an animated sprite 2D node. Some tutorials will also have you create a finite state machine using nodes in your character's scene tree, which is completely unnecessary. You'll just end up with a very cluttered character scene and even messier scripts. Let's add two area 2D nodes to the character scene, one as a hurt box to detect when the character is being attacked by an enemy, and another a hitbox so they can fight back. And give each a collision shape. It helps to color them different colors so you can easily tell which is which, so I'll make my hitbox red and the hurt box green. I'll make my hurt box the same size and shape as my character's environmental collider, and the hitbox an oval ahead of the character. I'll have the sprite node draw the character's idle pose from an atlas texture, selecting the first frame's region. We'll then create all of our sprite animations in the animation player by keyframing which sprite from the sprite sheet is being drawn by the sprite node. Setting this idle animation to 7 frames, looping, and using discrete update mode, now this works the same as the animated sprite 2D node. Recreating the rest of the animations, I'll just skip to the dash animation for now, change the first sprite frame, delete the rest, and set the length to half of a second. But after animating the sprite, we can add extra tracks to the animation to synchronize it with other nodes in the scene tree or call methods in any of our scripts. So during the character's dash animation, we could disable the hurt box so they can't be hit by enemy attacks during invincibility frames. I've toggled off the visibility of the hurt box too for demonstration purposes. This animation doesn't need to loop. Hiding the character's environmental collider will help show the hurt box. I've adjusted the invincibility frames to be a bit shorter and also told the character body to suspend gravity while the character is dashing. The same can be done for the character's attack animation. Most attack animations in games are split into 3 parts: anticipation, contact, and recovery. We only want the hitbox to be active during the contact phase to deal damage to the enemy, then turn it back off. And we can also tell an animated sprite 2D node to play an effect animation too. If a function call requires arguments, we can provide them in the inspector. When the character is walking, we can add a call method track to the animation to generate footstep sounds and particle effects synchronized with when the animation actually draws their feet touching the ground. and the same can be done for a running animation too. Now we just need to tell the animation player which animation should be playing using a finite state machine. If your objective is to learn how to write a finite state machine script, then by all means you should learn how to do that. But if you're learning to build a game with a game engine, then you should understand how to use the tools provided by that game engine. Computer Science 101 is to never reinvent the wheel. Either the tools provided will fit your needs, or you'll understand why they don't and you will be able to write a custom solution. So rather than writing our own finite state machine script, we can use an animation tree node, and give it a state machine resource in the inspector. After assigning the animation player property in the inspector, we can add animations as nodes in the state machine. This tool is much more efficient to use than writing a custom state machine script that does the same thing. We can also add more state machines as nodes too, creating multiple layers of state machines, which is really useful for keeping them organized. It also allows any state within the nested state machine to transition to a new state. Essentially, any state in a higher layer of the state machine will be able to interrupt those in a layer below it. So if the character is in any kind of movement state, they will be able to transition to either attack 1 or dash. All of the transitions leading to animations on this layer will have their advanced mode set to enabled, so we can initiate them via our script. And the transitions out of these animations are set to switch automatically at the end of the animation. Diving down into movement, we have jump and fall animations taking priority over the locomotion states: idle, walk, and run. There are also animations for looking up and down as alternatives to idle. All of the transitions in these layers are set to automatically transition based on the advance expression. The advance expression will be called on the animation tree's advance expression base node, which I have set to the character body 2D node. These transitions can now check properties and functions of the character body 2D node, checking whether the character's x velocity is equal to 0 to know if they should be walking, or if they've exceeded their walking speed and should be running. Alternative to the idle animation, the character can look up or down based on the value of a look direction variable, as long as their x velocity remains 0. Up one level in the state machine, we can check if the character's y velocity is more or less than 0, or if they are on the floor, to know if they should be jumping or falling. Back up at the root level, to activate the transitions to dash or attack in our character script, we can grab the animation node state machine playback and store it in a variable. Writing a public dash function, we can check which node the state machine playback is currently in by calling getCurrentNode, which returns a string name we can compare to check if they are currently in the movement state. Then tell it to travel to the dash state, and apply the dash velocity based on whether the character is facing left or right. I'll return true if the request to dash was successful or false if it wasn't. That way, if the request to dash fails, I can buffer the input and keep trying for a short time. Doing the same thing with the attack, if the character is in the movement state, I'll travel to the attack 1 state, or if they're in the attack 1 state, I'll travel to the attack 2 state. After setting up the input map to include dash and attack buttons, then an input handler script to react to these input actions, telling the character to do these actions, I'll turn on visible collision shapes from the debug menu and run the game. Now the character's footsteps are producing dust cloud effects every time they step. The dash animation turns off the character's hurtbox, creating invincibility frames. And the attack animations activate a hitbox during the contact phase of the attack animations. If you want to see how all of this was set up from scratch, you can find the full series of videos outlining the entire process on my Patreon. If you need help with this or anything else related to game development in Godot, feel free to join my Discord server. This is all part of a larger course on building a Metroidvania in Godot. It will also be available on Udemy in a few months and Skillshare after that. Until the next video. Thanks for watching.